Hello students, I am Devina Bhumik from Techno India Group Public School. Today we will continue our chapter Triangle. Today we will discuss about the solution of exercise 6.5. In this video we will discuss about the solution of question number 1, 2, 3, 4 and 5. This exercise is mainly depend on Pythagoras theorem and converse Pythagoras theorem. So start with question number 1. Question number 1 is sides of triangle are given below. Determine which of them are right angle triangle. In case of right triangle, write the length of its hypotenuse. Okay. Question number 1 is 7 centimeter, 24 centimeter, 25 centimeter. Okay. So you know that for a right angle triangle, hypotenuse square is equals to perpendicular square plus base square. This is the Pythagoras theorem. Or conversely, you can say that if in a triangle one side square is equal to sum of square of other two sides, then that triangle will become a right angle triangle and the angle opposite to the first side will be the right angle. It is converse Pythagoras theorem. So we will use this theorem and we will verify which angle will become right angle triangle. So start with part number 1. In part number 1, the side of the triangle is given as 7 centimeter, 24 centimeter, 25 centimeter. Okay, so let's check the solution. Sides of triangle is 7 centimeter, 24 centimeter and 25 centimeter. Squaring these sides, we will get 7 square as 49, 24 square as 576 and 25 square as 625. Okay, now if you add this 49 and 576, you will get 625, that is 7 square plus 24 square is equal to 25 square, that is the square of two sides is equal to third side. This side satisfies the Pythagoras triplet, hence these are sides of right angle triangle. We know that the hypotenuse is the longest side of the right angle triangle because hypotenuse square is the sum of other two side square. Okay, right, that is the hypotenuse is the longest side, hence the length of the hypotenuse will be the longest one, that is 25 centimeter. Similarly, part number 2, the sides are given as 3, 6 and 8. If you do the square of 3, 6 and 8, you will get 9, 36 and 64. If you add this 9 and 36, you will not get 64. That is 3 square plus 6 square is not equal to 8 square. Okay, so these sides do not satisfy the Pythagoras triplet. Okay, hence this is not the sides of right angle triangle. Okay, now part number 3, here is the sides given as 50, 80 and 100 centimeter square. 100 centimeter. Now again method is the same. Again square 50 centimeter, you will get 2500. The square of 80 is 6400 and square of 100 is 1 and 4 zeros. Now if you add this 2500 and 6400, it is not equal to 140. Okay, so you can say that 50 square plus 80 square is not equals to 100 square. These sides are not satisfying Pythagoras triplet, hence this is not the sides of right angle triangle. Okay, now fourth one, sides are given as 5 centimeter, 12 centimeter, 13 centimeter. 5 square is 25, 12 square is 144, 13 square is 169. If you add 25 and 144, you will get 169. That is 5 square plus 12 square is 13 square. So by Pythagoras theorem, this triangle forms a right angle triangle. Okay, and we know that the hypotenuse is the longest side, that's why the length of the hypotenuse will be 13 centimeter. Okay, so this one was very easy questions. Now second question, PQR is a triangle right angle as P. That means PQR is a right angle triangle where right angle is at the point P, and M is a point on QR. M is a point on QR such that PM is perpendicular to QR. PM is perpendicular to QR. Show that PM square is equals to QM into MR. Okay. So let's start this solution. First of all, I will consider angle MPR is equal to X. That means this angle I am considering this one as X. Now since PMQ is 90 degree, you can say that this is also 90 degree, right? Now if you consider the triangle MPR, okay, by angle sum property you can say that since this is 90 degree, this is X, so this angle will be 180 minus 90 minus X, right? 180 minus 90 minus X, that means this angle will be 90 minus X. Okay, right? So this is 90 this is equal to 90 minus X. Okay, done. Now again this angle is X. Okay, angle MPR we have considered as X, and this whole P angle is 90 degree. So you can say that this MPQ, that means this angle, okay, will become 90 minus X. Okay, right. Again this is 90 minus X. This angle is 90 degree. Okay, so you can say that this will be 180 minus 90 minus 90 minus X. Okay, by angle sum property in triangle MPQ. Okay, this M angle is 90 degree. This is 90 minus X. That means this one will be 180 minus 90 minus 90 minus X. That means it will become X. Okay, in this way, by considering one angle, I am evaluating the other angles. Okay, so let me erase these things and explain it again. So I have considered this one as X. I am getting this one as 90 minus X. This one is also 90 minus X, and this one is X. Okay, now if you consider QMR and PMR triangle, QMR means this one and PMR means this one. Okay, if I consider these two triangles, as you can see, MPQ means this angle, this X is equals to MRP. Okay, MRP. Sorry, MPQ means this angle. MPQ means this angle 90 minus X is equals to MRP. This is also 90 minus X. Okay, so MPQ is equals to MRP because both are 90 minus X. Again, PMQ means this one is 90 degree. PMQ, this one is 90 degree, and RMP is also 90 degree, so they will be equal to each other. Again, MQP, this means X. MQP is equals to MPR. MPR is also X. That means they are also equal. Okay, so by AA similarity, you can say that triangle QMP is similar with triangle MPMR. Okay, so since they are similar, so the corresponding sides of the similar triangle will be proportional. So you can write QM by MP is equals to MP by MR. Now if you do the cross multiplication, you will get MP square is equals to MQ into MR. Okay, in this way you have to solve question number 2. Okay, so when you are writing these two angles, in triangle QMP and triangle MPR, how you will write this notation? As you can see, here Q and here P, these angles are equal. So when you are writing two triangle, okay, you have to make the similarity of Q vertex with P vertex. Okay, again you can say that here M is 90 degree. Also for this triangle, M is also 90 degree. So that's why I'm writing here M, here also M. As you can see here, this angle is 90 minus x. That means for upper triangle, this P angle is 90 minus x. So that's why I'm writing here P. Okay, and here this R is 90 minus x. So that's why here I am writing R. So in this way I am comparing between the triangle QMP and PMR. That's why I am writing QMP and PMR. Okay, so in this way you have to solve question number 2. This one is very important question. Now question number 3. In ABD, in the figure, ABD is a triangle right angle at the point A. Okay, so this one is right angle. AC is perpendicular to BD, that means this is also 90 degree. Okay, show that is AB square is equal to BC into BD, AC square is equal to BC into DC, and AD square is equal to BD into CD. So let us start with part number 1. AB square is equals to BC into BD, into this BD. Okay, so let's start the solution. Here I am taking the triangle ADB, that is the whole triangle. ADB means whole triangle, and CAB, whole triangle, and this CAB triangle. Okay, so I am taking the whole triangle and the CAB triangle. Okay, this one and the whole one. Now you can say that this DAB, that means this angle, is equals to angle ACB. Why? Because they are both 90 degree. Okay, again for both the triangle, B angle is common, right? So you can write angle ABD is equal to angle CBA. Okay, so these two corresponding triangles are equal to each other. So I can say that by AA similarity, triangle ADB is similar with triangle CAB. Okay, now since they are similar, you can say that AB by CB is equals to BD by AB. Now if you do the cross multiplication, you will get AB square is equals to CB into BD. Okay, in this way you have to solve question number 3 part 1. Now part 2, you have to prove that AC square is equal to, this AC square is equals to BC into AC. Okay, BC into DC. Okay, so again you have to do this one as question number 2. This is same. Okay, so first of all you will consider, let triangle CAB is equal to x. This angle is x. Okay, and this whole A angle is 90 degree given. That means this angle is 90 minus x. Okay, again this C 90 degree given means this is also 90 degree. Again, if you consider ACB triangle, this A is x, this one is 90, that means this angle will be 180 minus 90 minus x. Okay, that is 90 minus x. Okay, now this angle is 90 minus x. Now again if you take ACD triangle, this is 90 minus x, this is 90 minus x, this one is 90 degree. So by using angle sum property, you can say that this angle will be 180 minus 90 minus x minus 90. Okay, that means this will be only x. Okay, so I am getting all the measurement of the angles. So now I will take triangle CBA and CAD. Triangle CBA, that means this triangle, and triangle CAD, that means this triangle. As you can see, triangle CBA is equals to CAD. CBA is 90 minus x, and CAD is also 90 minus x. Since both are 90 minus x, so these two are equal. Okay, proved above. Again, CAB is equals to CDA. CAB is x and CDA is also x. So they are equal because the measurement of both this angle is x. Now again, ACB is equals to DCA. Why? Because they are both 90 degree. So by using AAA similarity, you can say that this triangle is similar with this triangle. Okay, that means AC by DC is equals to BC by AC by equaling the ratio of the corresponding sides. Okay, so if you do the cross multiplication, you will get DC AC square is equals to BC into DC. In this way, you have to solve part number 2. Now part number 3. In part number 3, you have to prove that AD square is equals to AD square is equal to BD into CD. BD this one into CD. Okay, so let me just this one again and explain it. If you take DCA, this triangle, and DAB, the whole triangle, if you take this upper one and the whole triangle, you can say that DCA angle means this one is equal with DAB angle. Why? Because they are both 90 degree. Okay, again in DCA and DAB, D is common. Okay, so you can say that CDA is equals to ADB because D angle is common. Okay, so by AA similarity, you can say that DCA is similar with DAB. Now since they are similar, the corresponding side will be proportional, so that's why DC by DA is equals to DA by DB. If you do the cross multiplication, you will get AD square is equals to BD into CD. In this way, you have solved this question. Now question number 4. ABC is an isosceles triangle, right angle at the point C. Here is right angle. You have to prove that AB square is equal to 2AC square. Now this ABC triangle is already isosceles triangle given, and this one is 90 degree. Okay, and you know that in isosceles triangles, two sides are equal and two angles are also equal. If this one is 90 degree, that means this A angle and B angle will be equal to each other. That means this AC will be equal with BC. Okay, so given that ABC is isosceles triangle with AC is equals to BC and angle C equals to 90 degree. Now since ACB is a right angle triangle, by using Pythagoras theorem, you can say that AB square is equals to AC square plus BC square because AB is now hypotenuse, right? So in place of AB square, write AB square. In place of AC square, write AC square. But AC is equals to BC given. That's why in place of BC square, I am writing AC square. So I am getting AB square is equals to 2AC square, which I have to prove. So in this way, you have to solve this question. This was a very easy question. Now question number 5. Question number 5 is the converse of the previous one. ABC is an isosceles triangle given while AC is equal with BC. Okay, these two sides are equal. If AB square is 2AC square is equal to 2AC square, you have to prove that ABC is a right angle triangle. So I said that this one is converse of previous theorem, previous problem. Okay, so already given that AB square is equals to 2AC square. This 2AC square can be written as AC square plus AC square. Now given that AC is equals to BC, that means you can write AB square is equals to AC square. In place of AC, I am writing BC. Okay, so AB square is equals to AC square plus BC square. If you look at the figure, this AB square is equal to AC square plus BC square. That means one side square is equal to sum of other two sides square. Okay, so by converse Pythagoras theorem, you can say that this ABC triangle will be a right angle triangle. Which angle will be 90 degree? What I say, the opposite angle of the longest side will be right angle. That means here this C will be the right angle. Okay, and this AB will be the hypotenuse. That's why AB square is equals to AC square plus BC square. Okay, so this ABC will become a right angle triangle where right angle is at the point C. Okay, so in this way you have to solve question number 5. So this is all for today. Thank you.